Hello, everyone, and welcome to the latest episode of ARtillry Innovators, our video interview series with leaders in the VR and AR worlds. I'm Mike Boland, Chief Analyst at ARtillry, and my guest today is Robin Alter, who's VP of Strategic Partnerships at Ultrahaptics. So, Robin, welcome and thanks for joining us.
Hi, Mike. Thank you very much for having me.
Yep. So let's start with what Ultrahaptics does for those unfamiliar, and to kind of tee you up to do that, I'll first mention that as an industry analyst in this space, there's always things I'm looking at that are like the different balls in the air that we all have to get us to VR's true potential. And there's everything from positional tracking and resolution and frame rates and field of view and all those things that get us to kind of deeper levels of immersion and presence. And one of those technologies, which is probably the most kind of holy grail of all of them, is haptics. And we're seeing a lot of interesting technologies being developed, most of which, raise some adoption barriers because they're gloves or suits or other kind of wearable hardware. And Ultrahaptics is differentiating in some interesting ways by eliminating the need for those kind of, points of friction, arguably, and instead using ultrasound to create haptic feedback. So a very interesting approach. So to open things up, tell us a bit more about the company, the background, points of differentiation, and anything else I may have missed.
Sure. Well, you pretty much covered it, so I will I'll tread some old ground.
Yeah.
But you're exactly right. We provide haptic feedback using ultrasound, so you don't have to wear something, you don't have to hold a controller. You can get the sense of touch with just putting your hand up in air. We use ultrasound to vibrate the nerves on your hand so that when you reach out and touch something, there's an object or there's a texture or something right there in space. So I know it sounds like magic, but it's really quite cool, and it works.
Sure.
So so we've been in business for about 6 years. We are a spinoff of Bristol University out of the haptics lab there, and one of our founders left the university and put his PhD on hold, Tom Carter. And he started to build his PhD thesis into a company. About 3 years ago, we raised our Series A, and we have spent the last 3 years integrating our technology into applications across industries. So you'll see us in automotive, in consumer electronics, in casino gaming, and now in AR and VR.
Absolutely. Now, to give viewers here a sense of what it looks like, and we'll show some media here as well. The demo that I got when I saw you at SVVR was kind of like a small plate that created the kind of haptic feedback, and you're going to be kind of deploying this into lots of different use cases. So first, kind of, what does the hardware look like? And then also, what are the use cases that you envision? We talked about some cool ones when I met you last week, such as in auto, and you mentioned the casino thing. So what are some of the kind of real-life applications that you see coming out of this?
Sure. So the size, so basically we're using these tiny little speakers, the size of about the half the size of a dime almost in how big they are. And then we put them on an array, and we use them to fire at different times towards the bare skin that basically moves your nerves just enough so that you feel touch.
Yeah, and I can vouch for that, having gotten the demo. I mean, it does feel very realistic when your demo, for those that haven't seen it, or at least the one that you showed last week, was kind of just very simple, moving around blocks, but it's almost like you can really feel it, and it really adds to that sense of presence, which, again, is that kind of holy grail in VR.
Yeah, exactly. And if you think about it, touch really is, whenever you reach out and touch something, the nerves on your hand are essentially picking up a vibration. When you touch your skin, when you touch a fabric, when you touch anything, that's a vibration that your nerves pick up, and your brain translates into, hey, that's that material, or that's that object. And so we're essentially doing a very similar thing.
So I want to hear you talk about some of the advantages, both on the user end and also on the developer end. So starting with the user end, what are some of the advantages over some of the other methodologies, for lack of a better term, in terms of, I alluded to it earlier, some of the more kind of hardware-based things that require someone to buy an extra piece of hardware, wear it. So obviously there's that lower point of friction. Are there also benefits in terms of cost or, visceral advantage of the realism of the experience?
Sure. So there's a whole range of, let me answer that in a number of ways. So some of the barriers that we don't have is that when you walk into a space that has this technology in the walls or on or on a peripheral sitting on your desk, you don't have to wear something to get some haptic feedback. You don't have to, hold the controller and have it simulate a hand for you to reach out and touch something in VR.
Sure.
So we don't have the barriers of having to wear something, and wearing objects and wearing gloves and suits all have its place in the experiential realm. But when you're just trying to get things done or have a basic interaction, then just coming in and using your hands makes a lot of sense. I think that the use cases that really there are different value propositions as we are implemented in different use cases. For example, in cars, what's driving that use case is safety. When you drive, you just put your hand out in midair and you feel the knobs, buttons, and switches in your hand, and you can turn them in midair, and the radio on the dashboard goes on, or the AC goes up, right? And so that's a safety issue. You never take your eyes off just to see, did your gesture work?
Absolutely. What I love about that is it goes well beyond VR and a lot of the use cases you're talking about, and it's almost like another form of AR. When we think of AR, we always think of it graphically. It's an overlay onto our perception. This is almost a haptic overlay onto our perception, and in that way, it's very much AR, but not the way we usually think about it.
That's exactly. We're augmenting the world, and we have been for a long time. We're just doing it with your hands, and actually, with touch. One of the coolest kinds of use cases, which you're going to start to see a lot more happening with Ultrahaptics, is in the accessibility market.
Yep.
For disabled or elderly people whose vision and hearing may not be as strong, touch ends up being a wonderful way to guide, give messages, have them interact with the world. And so I believe that's going to be an incredibly strong and powerful market for us.
So moving from the user advantages onto the kind of developer or provider advantages, or all the other kind of folks you're working with, are there any kind of other kind of cost advantages or other advantages of this approach compared to more hardware intensive approaches, which tend to come with more capital requirements and other kind of economics? That, are there any other advantages on that front that you usually will talk about?
Sure. So first of all, I think that this is almost complementary to a lot of other haptics.
Yep.
There's of course overlap, but in general, if you have a plastic gun in an FPS in a VR arcade, the pullback, the recoil of it, you're not going to get that from what we do.
Yeah.
Or feeling a bullet on your chest, you're not going to have that kind of heavy impact with our kind of haptics. But if you want to interact with buttons, switches, and knobs, you want to fire electricity from your hands in a magic game. If you want to play chess and do different types of things, open doors, try to escape a room, then our kind of haptics make a lot of sense. And so the costs really are, right now, we're spending a lot of time with VR arcades, and
makes sense.
Location-based companies who integrate this into the walls, so that they don't have the barrier of having to, first of all, have users wear gloves or something else, or having the additional drain on the battery. And the cost for location-based customers gets distributed across a lot more content and users. So it makes a lot of sense for them. And over time, what you'll see is that we believe that our technology will be integrated into peripherals, gaming peripherals in particular, such as speakers, and will be available at very low cost for consumers in the market. And somewhere in there, like now, is where we hope to work with developers to start to show really cool use cases of their games and their applications where you can use mid-air touch to enhance the experience.
Well, that makes a lot of sense on two fronts. One, your go-to-market strategy in going after a lot of the VR arcades. I think that's where a lot of these VR experiences are going to scale in the near term before home ownership really starts to scale and penetrate the market. And I think I always say it's analogous to the 70s and 80s when, arcades were very much prevalent because, home console ownership hadn't reached that kind of cost barrier yet to make it tenable. So I think we're kind of seeing history repeat itself. So it's interesting you're going that route. And then also with speakers, I mean, that's a purchase people are already making. So there are certain kind of unit economic advantages of one piece of hardware versus several. So it sounds like also your go-to-market strategy is going to be kind of working with OEMs as opposed to an aftermarket solution, or is it both?
Well, yeah. I mean, I think right now we are very much focused on enabling other people to build products
Okay.
around our technology. I don't believe that we're going to in the next year release our own consumer
Got it.
device. I think other companies do that really well. We'd like to partner with them and make it happen more seamlessly for everyone.
Hmm. So going forward, what are the biggest kind of technical challenges you guys are currently facing? Because I think one of the coolest differentiating points of your technology is that kind of very proprietary, kind of from university research way that you characterize that. From a technical standpoint, what are some of the challenges? What are the kind of evolutions of this technology and its packaging and delivery that you think it's going to look like in the next few years? To the extent that you can talk about your roadmap, of course, but what's exciting on the horizon?
So on the horizon, one thing that we have a full team working on, which is part of us climbing over a technical barrier, is that we have a full team working on creating textures. So we have a
Hmm.
library of different sensations like firing electricity
Yeah.
or touching a
Water
plastic.
versus liquids versus solids, that kind of thing.
Exactly.
Yeah.
And so by being able to record sensations
Huh.
and the vibration of textures much more efficiently and put them into a library so anyone can just attach them to their objects, I think that's going to be really exciting because that's going to make everyone's development of whatever they're creating much more seamless, right? They'll be able to walk into a location-based environment with a headset on, and everything they see becomes haptic,
Huh. Yeah.
becomes touchable. So
So,
that's one of the challenges.
uh-huh.
I think also one of the advantages of what we do, and I think with more art, with more work and more just time, we're going to be able to send sensation over a much longer distance.
Oh.
So I'm
Huh.
excited about that, and we're really somewhat related to what's going on in the motion tracking space. But we support any of the motion trackers. So as long as they get more accurate, we're
Yeah.
already very accurate. We just need good data from the motion trackers.
Now, is the challenge in reaching those larger distance keeping it like so acute? Because wouldn't kind of the waves kind of spread too far?
It's a good question,
Yeah.
but essentially, sound waves don't disperse
Oh.
like
Okay.
like air,
Yeah.
and so it's not a fan. These are sound waves, and you can put a sound wave into a very specific spot, and you
Huh.
can direct a bunch of sound waves into that spot. So we don't have a strong an issue with that.
Okay. So, to kind of end out, like we always like to do on a like kind of practical note for a utility for our viewers here, what are your kind of current business objectives? What types of partners or customers or distribution channels are you looking for in case, any of them are out there watching?
Sure. So I'm looking for a few things. I mean, I build partnerships. I handle partnerships at the company, and
Hmm.
so some of the partnerships are with developers who have really cool apps, or they're targeting, say, the arcade market, and they would like to add something special to make their content more attractive to the arcades. And so having haptics makes a lot of sense, and then we go in with them and bring in their apps or show them in the press and conferences, and they get a lot of exposure.
Yeah.
So that's one thing. Developers, I'd love to talk to. I'm from the game development world, and so it would be exciting to work with more of them. And then there are plenty of channel partners who are building stuff for other customers. We
Ah,
work with a number. We have a channel program where we enable service providers to get our technology so they can build interesting solutions for their customers.
that's
Those
great.
are the
Well,
main kind of partnerships I've been doing.
nice. So we're gonna have to end it there. We're out of time, but I want to thank you, Robin, for joining us.
Great. Thank you so much, Mike. It was fun.
Yeah, and thank you all for watching. Stay tuned for more episodes and more published material and market coverage and insights and lots of other formats we're developing at Artillery, which you can find at artillery.co. So this has been Artillery Innovators. I'm Mike Bolin. Thanks for watching.